My name is Phil Overholt, and I'm the program manager for transmission reliability R&D. Let's see, that's the last slide, I think. At the U.S. Department of Energy, and I'm also the technical project officer for 10 of the Smart Grid Investment Grant projects that are dealing with installing the phaser technology. I'm delighted to be here and somewhat humbled to be here in the presence of so many eminent speakers, but delighted to be able to be here in honor of Professor Phadke and Professor Thorp as PMU pioneers and as educators and mentors and engineers, and you name it. You heard a lot last night of what they contributed. So I'm going to talk a little bit about these various topics. This is sort of the timeline. I want to cover mainly what DOE has been doing, but not in any depth, because we have a whole list of people that are going to be able to talk about that coming up. So one of the earlier papers I did find that dealt with phaser measurement technology was a paper in it died?
Yeah.
I'll just speak up. A paper that was from 1993, but then going forward, we had a workshop in 1991 that was looking at the idea of real-time control in the power system, and many people in this room were at that workshop. And as a result of that, we got started again in broader programs supporting synchrophasor technology. Then the Western Interconnection blackout was on August 10th, and I'll talk a little bit more about that later. Around 2002, we put together what we call the Eastern Interconnection Phaser Project, and that project was designed to increase the installations of PMUs in the Eastern Interconnection. The West had been working to put a lot of PMUs in place, particularly BPA and Southern California Edison. Then the Eastern Interconnection blackout took place, and that caused us to accelerate the work from that point on. M.S.E.E. was formed a little later because the Energy Power Act of 2005 designated NERC as the reliability organization. So NERC reestablished itself as a North American Electric Reliability Corporation, and took over the leadership of M.S.E.E. because we wanted to go nationwide. And DOE stepped back a little bit into the area of developing applications to use synchrophasor data. Then shortly after that, we had celebrated designating PMU pioneers, and I'll talk about that. And then the Recovery Act projects starting in 2009. These are just some of the titles and some of the work that went on with DOE working through the Oak Ridge National Lab. This is sort of a sample of the projects, and of course, Dr. Phadke and Dr. Thorp are prominent authors on many, many papers. And Mark Adamiak, we'll hear from later, he certainly was in the game too. So in the two blackouts I mentioned, the graph on the left shows, on the bottom shows what we thought was going to happen from a simulation of in the West for that grid. An event like occurred would settle out to another level of power, and the system would keep operating. But on top, there were PMUs installed, and were able to capture that. That is the final like minute and 15 seconds where we had a negatively damped oscillation just before the breakup in the western interconnections. So that was a clear indication. You really couldn't see that unless you had the synchrophasor technology and high-speed recording. Then on the right, this another very familiar graph in the western interconnection, the eastern interconnection, August 14th blackout, the largest blackout in U.S. history, had we're showing the phase angle between Cleveland and Michigan, and that phase angle was abnormal at the start of the day and certainly deteriorated as the day went on. And again, you couldn't see this effect with just the SCADA technology, so it reinforced again that we needed the synchronized measurements to really capture that. So then moving back to M.S.E.E, these are PMU pioneers we designated and honored at that time. Of course, Dr. Phadke and Thorp are prominent there for their work. Barack Obama was, Edison was sort of the southern half of the team of BPA and working on the West Coast. We have, of course, Ken Martin's here, he'll speak later. John Hauer worked in wide area measurements. Bill Middlestat was part of the team. I mentioned Mark earlier, and Ed Schweitzer put PMUs in his relays and protection devices long ago. The guy over on the this side over here was built some of the first PMUs, and I knew he would be here, so I'll point to Jay here as he's looks a little different today than he did then. I'm guessing it's around 1990, but I'm not sure. But he's there.
Your technology has matured.
So, and to me, there are many other pioneers probably in the room today that need to be recognized. So when DOE got into advanced synchrophasor technology, we had awarded those 4 projects in 2009, and the Virginia Tech was one of them, and they were working with a 3-phase tracking state estimator, and then the others were working with various applications. And then on the right here, these awards were made to universities to work with a vendor or other partners to collect synchrophasor data that they could use directly at the universities to get that data in-house and do data mining and look at, and also to help establish a curriculum where they could increase the knowledge of synchrophasor technology in the university community. And again, Virginia Tech was one of the award winners. These are on the OE website, the DOE website. These were just announced last week. These are the synchrophasor projects in the ARRA area in the smart grid investment grants. The top 5 are independent companies, and the bottom 5 are RTOs, ISOs, or WEC. And so the numbers after the bottom 5 are the number of transmission operators that are installing equipment. And so if you add all those up, there are over 70 organizations across the U.S. that are installing synchrophasor equipment and systems. We require them to install 2 or more PMUs, a communication system, a PDC, and implement 2 or more applications. So the total cost over $300 million, and DOE share is about $150 million. I'll move on to the last slide here is sort of a summary of where we were and where we are now. On the left, in 2007, there were approximately 170 PMUs installed across the U.S., and that was after about 5 years of accelerating installations in the Eastern Interconnection. So on the right, in November 2012, this amounts to about 600 PMUs installed as of that date, and we still have another year and a half to go in installing additional PMUs, and I expect there'll be like 1,200 PMUs installed by the end of the implementation period of all these projects. It's a couple things about these projects. It costs less to install these systems and PMUs than we thought it would. So the funds that we have are being used to install PMUs beyond what was proposed. The other finding was there are a lot of digital fault recorders in a lot of substations across the country, and they can be we can draw the Synchrophasor speed data out of those DFRs, and they're also connected at many locations in the substations. So we have a lot of signals that we can call on immediately, and that was a surprise, but it was a pleasant surprise. So I don't think I have time for questions, so I'll turn it over to the next speaker.